I welcome you all in this lecture on introduction to simulation, and this lecture is part of our course through which you are going through, that is modeling and simulation of dynamic systems. Now simulation basically as the name indicates that we want to do something numerically, but many times simulation also means that trying to imitate or trying to find out the behavior of something, when it is not actually happening, that is what is the literal meaning of it. And this simulation we could do using hardware as well as software also. Hardware, for example, if you have a very big mechanical system, say a huge mechanical system is there consisting of large amount of mass, spring having very high stiffness, and likewise damper. So we can see if you want to do certain parametric study for this type of system, then what we have to do is that it will be difficult to make any variations there. Okay. So what simulation through hardware, what do I mean that what people used to do is that they find out a electrical equivalent of this simple mechanical system, where it consists of resistor, inductor and capacitor, and then they do the manipulation in equivalent electrical system in order to look at do the parametric study. But here the lecture which I am going to talk to you rather than experimental simulation, what we would like to be doing is that we will be talking about the numerical simulation. So mathematical models of dynamic physical systems have been made since the differential equations have been invented, and these differential equations have been actually a great boon for the dynamic modeling or mathematical modeling of the dynamic system. Now earlier these equations could not be analyzed due to lack of computational devices. Earlier computers were not that powerful, so it was difficult to analyze these equations using the existing computational devices those time. The prediction of dynamic behavior was limited to low order linear models, and that too was not accurate, because when you create a linear model, naturally you you make many assumptions in order to convert the real physical problem into a real physical problem, which is always a non-linear problem, and when you want to convert that non-linear problem into the linear problem, you make many assumptions, and because of that these models were not very accurate. Now coming back to the definition of simulation, simulation basically refers to procedure of solving the equations that resulted from the model development. So when we have a physical model, or mathematical model of the physical system, then we try to solve the equations which has come after creating a model of that system. Now the question is, how do we solve those equations, or mathematical models? Fine. So simulation basically refers to the procedure of solving the equations that resulted from the model development. I can just cite one example, say numerically solve a set of differential equations with different initial and say and boundary conditions. Okay. So, we may have the different initial and different boundary conditions, and for that differential boundary conditions my intention could be solving of this a model, and this is what is called a simulation. Now, before I move further, we will be talking a lot in this lecture by taking a simple example of say spring mass damper system, and of course, this model you can get this model we can get, or this model represents the many physical systems. For example, I have taken in my earlier lectures, I have talked about modeling of a water tank, and we could always make this type of model for a system. Say that if I have got a simple car, okay, and I want to mathematically model it, then the equivalent suspension system, whatever suspension system this system has, I can represent that suspension system using spring and damper, and the model of mass of the car I can represent by a lumped mass. Okay. So, from here I can try to simulate this system equation for say if I am interested in knowing the behavior of this car for the motion, the vertical motion this way. Okay. So, this is the M, and we have the suspension system being represented by the spring and damper system. So, the expression for this, suppose this is subjected to certain excitation, say F t, okay, then the system equation could be mx double dot plus k rather let me write this term later. So, plus I can write R x dot plus k x is equal to F t. Okay. So, the simulation here basically means that I want to solve this equation, this differential equation, and when it is subjected to different type of initial or boundary conditions. Now, a simulation of a system is the operation of a model which is representation of that system. Okay. So, we are basically operating on the model, and that model actually represents your physical system. Now, the model is amenable to manipulation, which would be impossible, too expensive, or too impractical to perform on the system which is portrait. So, for example, say I want to see the performance of the different stiffnesses on say the vertical motion of the car here, then naturally if I am doing it on the real physical system, I need to replace the suspension system, and then I want to see the vertical motion here, and again apart from those hardware, I also require some device measurement devices for measuring of the vertical motion. But in mathematical modeling and simulation, we can change these stiffness and damping values, and we can see the behavior. So, this is what I mean by the model is amenable to manipulation. The operation of the model can be studied, and from this properties concerning the behavior of the actual system can be inferred. Now, let us see the simulation technique as such. Now, as I was telling you, for a given mathematical model, sometimes it is possible to derive information about the system by analytical means. Now, as we will be seeing the difference between the analytical way of solving the problem and simulating the problem. So, Uh, uh, but this analytical method or analytical way of solving the problem is not always possible. Okay. So, whenever it is possible, of course, we try to go for the analytical method because it gives us the general solution, whereas the numerical methods gives us the solution for the specific case, that is for the specific set of values, and that too for the specific set of initial conditions. Okay. So, when it is not possible, numerical computation methods are used to solve the equation. So, as I said, if your system becomes complicated and it is not possible to derive the analytical expression, analytical solution for the given system, then we resort to the numerical computational technique, okay, in order to simulate or solve the equations. The solution provided by the analytical methods are general, as I just explained you, whereas the numerical method produce simulation solution in steps. Okay. So, the analytical method gives you the general solution, whereas simulation numerical methods produces the solution in step. Each step gives solution for one set of conditions and the calculation must be repeated to expand the range of the solution. Okay. So, this is what has to be done in case of the numerical method. Dynamic models which of course is our principal component of our course here. So, the dynamic model can be solved analytically, say for the automobile wheel model. So, this model which I just talked to you, this model we can solve a simplified model, say simple 1D model of it, this can be solved analytically. Okay. And of course, if I want to solve this model numerically, the simulation has to be done, which is solving the equation of the model step by step with increasing values of time. So, we solve the model step by step with increasing value of time, and this is what we call it as simulation. Now, so the current value at any step of computation represent the state of the system at that point of time. Okay. So, this is what we mean by, or what we mean by yes, the current value. It basically states the it represents the state of that system at that particular instant of time. Now, there is a term you will find in literature, and that term is the system simulation. Okay. System simulation, basically it is a technique of solving problem by observing the performance over time of the dynamic model of system. So, if we want to solve a certain problem, then we observe the performance of over the time of the system, okay, of the dynamic model of the system, and that is how we solve that problem. Now, this definition also includes dynamic physical model in which results are obtained from the actual measurements rather than the numerical computation. This I talked to you about this during my introduction for this particular lecture, okay, where I talked to you about the actual physical measurements, okay, from the dynamic physical model. Okay. So, that is there. Now, let us see what is the how do we compare, or how do we see the advantage and disadvantages of the simulation and the analytical methods. So, as I said, the analytical method gives us the general solution. Okay. So, from general solution we can infer about the behavior of the system, whereas the simulation results gives us the specific solution for a specific set of input parameters and the initial conditions. Okay. So, if we take the example of the same automobile motion which I have just discussed here, analytical solution gives all the conditions that can cause oscillations. Okay. So, we can say if I talked about say oscillatory behavior of this particular equation, then the analytical solution gives all the conditions that can cause the oscillations. Now, if I talk about the same example, solving the same example that is the automobile motion through simulation, then here you see that the each execution of simulation indicates whether for that set of condition the car will oscillate or not. Okay. So, whatever numerical values you have chosen, okay, and whatever your conditions are there, input variables are there, input parameters are there. So, for that, for each execution of simulation you will get with come to know whether the car will oscillate or not. And of course, if you want to have a broader idea about the behavior of the automobile motion, naturally you need to perform the number of simulations. Okay. So, you need to go through more number of simulations, and that is what many times we call it as the numerical experimentation. Okay. Carrying out the simulations many times, and that is what we call it as the numerical experimentation. These analytical methods are preferable when solution is sought for some maximizing condition. Okay. So, if I want to solution for some maximizing condition, then we prefer this analytical method, but here and this maximizing condition we can get by a single mathematical solution can give us such maximizing condition. Okay. But if I talk about simulation, here you require the many simulation runs are needed to find a maximum value. Okay. And here we cannot tell whether it is local or global maximum. Okay. What do you mean by local and global maximum? I hope all of you know that. Say if some behavior is like this, you have some parameter and say here time, some behavior is like this, okay, and some behavior is like this. So, something is say in this range, this is the what we call it as local maxima, in this range this is the locally maximum value, where here this is the global maxima. So, that thing we cannot tell, we cannot find out, we cannot tell whether it is a local or global maxima using the numerical simulation. Analytical results may have complex series of integrals which need extensive evaluation. In fact, this is one of the big drawback of analytical results, that it may have a complex series or integrals, and those integrals or complex series needs extensive evaluation. Okay. But you can see that the ease with we get the simulation results, especially with powerful computation tools and the powerful software which carry out the numerical integrations very easily, as well as there are many visualizing tools such as animation tools. Okay. These simulations have become one of the preferred method of finding out or looking at the behavior of the system. So, experimental nature of simulation. So, as I was talking to you the numerical experimentation which we call it, that is we go for the many number of runs, okay, we go for the many number of runs of simulation. So, this simulation is an experimental problem solving technique basically. So, this is what we call it as the numerical experimentation. Many simulation runs are performed to understand the relationship involved in the system. Okay, we need to perform the many number of simulations in order to understand the relationship in the system. Thus, use of simulation in a study must be planned, okay, as a series of experiments in order to understand the behavior of the system. And if you are not going to plan, or if you have not planned your simulation study, then you will be randomly doing something, okay, and you may not be able to reach to any conclusion out of the simulation results which you are getting, okay. So, one need to understand and one need to plan about the simulation study, okay, as a series of experiment in order to understand the behavior of the system. There are principally two types of simulation which we usually come across. One is the continuous simulation and another is the discrete event simulation. We will discuss details of each type of system simulation method. Okay. So, the continuous simulation basically it is used for continuous system. So, if you are modeling a continuous system, then we use the continuous simulation. I have discussed these things, some of these things in my earlier lectures where we have talked about the models. Okay. Now, it is characterized by change of state variable continuously with time. Okay. There are some details available about state variable. In fact, one of my lecture is only on the state variable formulation, where you will be finding out details what are the state variable formulation, but for the moment you just understand that state variables are basically variables through which you can study the behavior of the system. Okay. So, that is there. Now, mathematically they are represented by differential equations, that is the continuous system. Okay. They are represented by the differential equations which gives the relationship for the rate of change. Okay. And only simple differential equation can be solved finding the values of the state variable analytically. So, that is what I said, and using numerical analysis techniques to integrate the equation and give values of the change of the state of variable. So, we can use the numerical analysis technique to integrate the equations and give the values for the change of state of the variable. Okay. So, that can be done. Now, coming back to the discrete event simulation, this simulation method is used for the discrete systems. Okay. The simulation method is characterized by the change of state variable instantaneously at separate points in time driven by events. Okay. And an event is defined as an instantaneous occurrence that may change the state of the system. Okay. The limitation of the method is that simple system can be manipulated by hand calculations. Okay. Real time systems are too complicated for this manipulation. Okay. Of course, we can use the digital computers for the simulation purpose. Now, if we want to simulate something, what should be our sequence of events? Okay. So, the simulation process basically consists of, first what you have to do is that you have to describe the problem, Then you have to, after you have described the problem, you have to give the definition of the problem, definition of the model. Okay. So, from the description of the problem, actually you formulate your model and you give the definition of the model, and once your model is ready, then you decide whether you want to go for simulation or you go for the analytical methods. What method you want to solve your model, that decision you have to take. Then if you want to decide to simulate, you have to plan your study, okay, what all simulation study you are going to arrive, and after you have planned this thing, then what you do, you write a program. Now these days you can write this program in any of the language, okay, C, C++, MATLAB or Mathematica, any language you can code that, okay. Then you have to validate that model, okay, you have to run the model, and if the result is not good, then you may have to go for more number of runs and then finally verify the result. So, this is how the simulation process consists of. Now, there are different simulation softwares available in the market which you can take help in your simulation exercise. Okay. So, there is a classification of simulation software. It could be a general purpose software or it could be an application oriented software, and the modeling approaches could be event scheduling approach or the process approach. Common modeling elements could be entities, attributes, resources, queues, okay. And here are the desirable software features these days which mostly people are interested in, that you should have the modeling flexibility and ease for use, hardware and software constraints, animation. I talked to you little earlier. Animation basically gives us the actual behavior, actually the depicting as if the real system is working, and these animation results are usually prepared through the simulation data which is available. So, this animation is basically the visualization of your result. What you can say is that a better way of visualization of the result. Then if some statistical features are there in your software, it is very good. Customer support and documentation and output reports and the plots, okay. So, these are some of the desirable software features which should be available with the simulation softwares. There are again certain advantages and disadvantages of the simulations. The advantage, if you look at, it can be used to study existing system without disrupting the ongoing operations, okay. The proposed system can be tested before committing resources, allow us to control time, allow us to identify the bottlenecks you can identify, allow us to gain insight into the model, which variables are most important to the system performance. And if you look at the disadvantage of simulation, see, the building of model itself is art as well as science. So, first of all you must be comfortable in creating the model of the system. Then the quality of analysis depends on the quality of the model and the skill of the modeler. Simulation results are sometimes hard to interpret, that is also there. One should have the understanding of the behavior of the system, actual behavior of the system. Then from that understanding you can interpret the system. Simulation analysis can be time consuming and expensive also, and it should not be used when an analytical method would provide the quicker result. So, that is what we should do. So, if you want to further read about this chapter, you can refer the system simulation book by Gordon. Thank you.